Hello everyone, welcome back to TechOps tutorial. In this video, we are going to talk about package management tools and repository in Linux. Now, if that sounds a bit technical, don't worry, we are going to keep it simple and beginner friendly. By the end of this video, you will understand how Linux install, update and manages the software using a packages and tools that makes the whole process smooth and efficient. So let's get started. Alright, before we move ahead, let's first understand what package management really means. In simple words, it's a system that helps you to install, update, configure, or remove the software on your Linux system, and it does all this in a smooth and reliable way. But why is this so important in Linux? Well, many Linux programs depend on other software. These are called dependencies. Managing these by hand can get tricky. That's where package manager comes in. They handle all the dependency for you automatically. Think of it like a Play Store on your phone, a central place where you can find and install and manage the trusted application. The difference is on Linux, you usually do this through the terminal. Alright, now let's break down what exactly a package is in Linux. A software package is basically a compressed file that holds everything needed to install and run specific application. It's a kind of like a zip file, but for a software. Inside this package, you will find program binaries, configuration files, metadata, dependencies. Let's see one by one. Program binaries. These are the actual files that makes the program work, like the executable file and libraries. Next is configuration files. These files stores the setting that helps the program run the way it's supposed to. Next is metadata. This includes the important information like the version of the software, what system architecture it's for, and who maintained it. And the next is dependencies. These are other packages or software that the application needs in order to run correctly. Without these, the program might not work properly. So, think of the packages as a complete bundle that includes everything you need to get a program up and running. It's not just one file, it's a collection of files that works together to make sure the software functions smoothly. Now let's talk about something called package manager. A package manager is a tool that makes your life a lot easier when you are using Linux. It helps you to install, update, remove and manage the software on your system, all with just a few simple commands. Let's break it down. Installation. Want to add a new software? Just run a quick command, no need to manually download or build anything. Next is upgrade. It keeps your application updated with the latest features and security fixes. Next is removal. Don't need a program anymore. You can safely uninstall it and even clean up leftover settings if you want. And next is dependency resolutions. If a software needs other tool or libraries to work, the package manager handles all that for you. So in short, it takes care of all heavy lifting and makes software management on a Linux super simple. Alright, now let's take a quick look at some popular package managers because different Linux distributions use different tools and formats. Here is a quick breakdown. Ubuntu and Debian use .deb packages and the common tools are APT and dpkg. Next is Fedora RHEL, Rocky Linux and Alma Linux, which uses .rpm packages with DNF or the older yum. Next is Arch Linux, which use the .pkg, .tar, .zst format with the Pacman package manager. And the next is Alpine Linux, has its own format .apk and use apk-tools. And then we have a universal package systems like Snap, Flatpak and AppImage, which work across a multiple Linux distro no matter what base they use. So depending on Linux distro, the package manager and the file format will be the different, but they all serves the same purpose, managing your software. Let's talk about something really important called dependencies. Most software on Linux does not work alone. It often needs other programs or libraries to run properly. These are called dependencies. Think of dependencies like ingredients in a recipe. If you are baking a cake, you need flour, sugar, and eggs. Without any of these, the cake would not turn out right. Similarly, if the required dependency aren't installed, the software won't work correctly. The good news, Package Manager automatically figure out and install all the dependencies for you when you install a program. Without them, you would run into something called dependency hell. That's when missing or conflicting dependencies cause a big headache and makes installation software really frustrating. So, managing dependency properly keeps your system stable, secure, and saves space by sharing a common libraries. Okay, so do package managers differs between a Linux system? The answer is yes. Every Linux distribution usually has its own package management system, but even though the commands and the tools look different, they all do basically the same thing. For example, on Debian and Ubuntu, you would use apt install nginx. On Fedora or RHEL, it's DNF install nginx. On Arch Linux, you would type pacman-s nginx. And on Alpine Linux, it's apk add nginx. Even if the command change, all package manager help you to install, update and remove software, automatically handles dependencies, keep track of installed packages, make sure everything is safe and verified. So different tools but the same purpose, making software management easy. Let's see what happens when you run a command like sudo apt install Firefox to install the software on Linux. The package manager does not just blindly install the program, it goes through a few important steps to make sure everything works smoothly. First is connect to repository. First, it connects to a software repository. These are like online libraries where all the software packages are stored. Next is fetch metadata. Then it downloads the information about the package like its version, what dependencies it needs, and a description. Next is to resolve the dependency, it figure out if there are any other packages required and plan how to install everything properly. And the next is download and install. After that, it downloads all the necessary files and install the software on your system. And the next is update package database. It updates the system packages database to keep track of what's installed for further updates or removal. All these steps happens automatically, so you don't have to worry about a thing. Now let's talk about something called a repository. A repository is like an online storage place where the software packages lives. When you install a software with a package manager, it gets the file from this repository. There are three main types of repository: official repository, third-party repository, local or offline repository. Let's see one by one. Official repositories. These are maintained by the Linux distribution own team. They are tested carefully, secure and guaranteed to work well with your system. Usually, these are set up automatically when you install a Linux. And the next is third-party repository. This comes from the developer outside of the main Linux system. They often have newer version of software or application. You won't find it in official repository. For example, Ubuntu uses something called PPAs. that is personal package archives. Next is local or offline repository. Sometimes system don't have internet access. In those cases, you can use the local repository which is stored on UBS drive or an internal network. This is super useful for a business or a secure environments. Sometimes you might want to install software without using a package manager. This is possible, but usually not the best choice if you are just starting out. Here are some ways people do it. Source code compilation. You download the source code, usually in tar.gz file, then manually compile and install it using command like .configure, make and sudo make install. This takes more technical know-how and can get complicated. Next is binary installer. Some software comes as a self-contained installer script like .sh or .run files, which unpack and install the program for you. Next is portable format. There are also formats like AppImage, which bundle everything needed to run the application, so you can just run it without installing. And the last is universal package. Tools like Snap and Flatpak work across many Linux distributions, running application inside a sandbox for better compatibility and security. But remember, for most users, package manager are the easiest and safest way to install any software. Now let's see how package manager keeps track of all the software you have installed. They maintain a central database that stores the detailed info about every package on your system. Here is what they keep a track of: the name, description, and the current status of each package, whether it's installed, removed, or completely wiped out. The version number and update history, so they know when to upgrade or avoid conflicts. Where each file from the package lives on your system, which helps when updating or removing the software. This database also helps with a system audits and troubleshooting, like checking if everything is intact or spotting configuration changes. Basically, it's like having an organized list of all your software to keep things running smoothly. Keeping your Linux system up to date is super important. It helps to protect you from a security risk and gives you the latest features. Different Linux distributions use different commands, but they all do the same thing: refresh the software list and update your programs. For example, on Ubuntu or Debian, you run apt update && apt upgrade. First, it refreshes the list of available software, then upgrades all the packages to the newest version. On Fedora or RHEL, the command is DNF upgrade. It does both refreshing and upgrading in one go. On Arch Linux, you use Pacman-SYU. Here S means sync, Y means refreshing the database, and U means upgrade the packages. Doing these updates regularly keep your system secure and stable. So now let's understand uninstalling software. Removing software on Linux is just as easy as installing it. Thanks to Package Manager, you can choose how much you want to remove, just the program itself or the program plus its settings. Here is how it works. Basic removal. This uninstalls the software but keeps its configuration files in case you want to reinstall it later. For example, apt remove package name, DNF remove package name, Pacman-R and followed by the package name. Purging configuration files. This removes the software and all its settings, giving you a complete cleanup. Commands looks like apt purge package name, DNF remove --remove -leaves followed by package name, and the last is Pacman-RN followed by package name. And the next is auto remove unused dependency. Sometimes when you uninstall software, Some extra packages are left behind that aren't needed anymore. You can clean those up with commands like APT auto remove, DNF auto remove, Pacman-rs, Pacman-qtdq. So package manager helps keep your system clean and tidy. Next is universal package system. Let's talk about some modern package format that works across many different Linux distributions. These are great alternative to the usual distro specific package manager. First is AppImage. It's basically a single file application that you can just download and run. No need to install anything. It's portable, has minimal impact on your system, and is perfect if you want to quickly try out some new softwares. Next, there is Snap, developed by Canonical, the team behind the Ubuntu. Snap works on a lot of Linux versions, connects to a central Snap store, and update your application automatically. It supports both desktop and command line application. Then we have a Flatpak. Flatpak focus on security by running application inside a sandbox, keeping them isolated from your system. It uses decentralized repository mainly for graphical applications, with FlatHub being the main place to find application. All these universal package system make it easier to get and run software no matter which Linux distribution you are using. Alright, let's quickly review the main point from this tutorial. A package is a bundle archive that contains everything your software needs: program files, settings, and important information. And the next is package manager, which is a tool that automates the installation, updating, and removing the software, and it also takes care of dependencies for you. And the next is repository, and a repository is a trusted place where the software packages are stored. These can be maintained by a Linux distribution team or by third-party developers. The main goal of all this is to make a software management easy and consistent across a different Linux system, so you don't have to worry about manual handling dependencies or compatibility. Before we wrap up, there are some best practices to keep in mind. First, learn your distribution package manager. Spend some time getting comfortable with the tools like APT, DNF, or Pacman. Each one has its own strength and ways of doing things. Second, prefer official repository whenever you can. Software from official repository is tested, secure, and maintained by a Linux community, so it's usually the safe choice. And lastly, for software that's not available in official repository, consider using universal formats like Flatpak, Snap, or AppImage. They are safer and easier alternative to manually installing the software. Following these tips will help you to manage software smoothly and keep your system stable. Thank you so much for watching this tutorial. We hope it helped you understanding how package management works in Linux and give you a confidence with the different package managers. If you have enjoyed this video, don't forget to subscribe to TechOps tutorial to stay updated on more Linux automation and infrastructure topics. We would like to hear from you. Please leave your feedback and any topic ideas in the comments below. And keep learning. Check out our other beginner friendly Linux tutorial. Thanks for watching, and I will see you in the next one.